Let's solve this quadratic equation by completing the square. Our first step will be to move the constant to the other side. We subtract 7 from both sides. Our next step is to divide by the leading coefficient. We'll divide by a. We divide all terms by 4. 8 quarters is 2 wholes. 7 quarters we cannot reduce. After doing this, it's time to identify what is b. b is a -2. We will half it, square it, and add it to both sides. Half of -2 is -1. We're going to add the square of -1 to both sides. After doing this, we can factor the left-hand side. I like to cut to the chase, but we'll take it in slow motion. -1 squared makes +1. On the right-hand side, I can work to simplify. -1 squared, again, is +1. On the left-hand side, we can factor this perfect square trinomial into x and x with same signs. Both signs are going to be negative. The factors of 1 that add to make 2 are 1 and 1. On the right-hand side, we can combine like terms. To do so, we need a common denominator. 1 whole is the same as 4 quarters. Back to the left-hand side, we notice that we have the same binomial twice. On the right-hand side, -7 quarters and +4 quarters makes -3 quarters. Our job is to solve for x. To do so, we need to isolate x. The farthest thing from x is that squared power. Let's reverse the square, taking the square root. What we do to one side, we do to both sides. We're able to take x minus 1 out from underneath the radical. We expect 2 solutions, a positive root and a negative root. The square root of 4 is 2. The square root of a negative is I. 3 is not a perfect square, and it remains inside the radical. X is almost completely isolated. Our final step is to reverse subtraction with addition. We will add 1 to both sides. Our answer is 1 plus or minus I square roots of 3 divided by 2. Same answer with a different method.